Hello bachcho, let's read the question. So the question says, a solid uniform cylinder of mass m performs a small oscillation due to action of two springs whose combined stiffness is equal to x as given in figure 4.81. This is figure 4.81. Find the period of these oscillation in the absence of sliding. So we are given with the case that there is no sliding in this case. So let us first understand the question. So to understand it well, we have to make a diagram. So we have two springs attached here like this, and let's suppose the cylinder has rotated with an angle theta. So this will be, let's suppose this was point A and this was point B. So this will be point A and point B will be somewhat here, and let this new point be A dash and its opposite be B dash and the center be O. So let's suppose the angle AO A dash is equal to theta. This is the angular displacement suffered by this cylinder. Now let us first revise the key concepts behind this question. So the key concepts behind this question are, first is the moment of a force. The moment of a force is given by F, which is force into the distance between the force, with distance between the arms, which is in this case comes out to be equal to 2r, because the total distance between the 2 points will be this. Okay, so now the second key concept here, it is the moment of inertia. So moment of inertia at a point other than center of mass. Okay, other than center of mass. So it is given by IO. Let's suppose we are talking about point O. It will be equal to moment of inertia at point center of mass, which is Cm, plus m into distance between the center of mass and the point O, which is r in this case. So IO will be the moment of inertia at center of mass plus mr square. Okay, so these are two important concepts which we need to consider in this question. Now let us jump right into our solution. So in solution part we have here A dash can be written as r into theta. Okay, by the principle of circles. So A dash can be written as r into theta whole twice. So this will be equal to A dash. Now the x, from here we can write extension in one spring. What is extension in one spring? Which will be equal to the contraction between contraction in the another spring. It will be equal to r times theta, and it will also be equal to contraction. Let us write it. Okay, so now as theta is very small, we can write the force in force due to force being applied in the cylinder. It will be equal to due to spring 1 as well as due to spring 2. So it will be equal to restoring force, which will be equal to K times r theta plus k times r theta will be equal to 2k r theta. Okay, so this will be the force, restoring force acting on the cylinder. Now in the next part we can write the moment of this force. What will be the moment? So we will find out moment of this force will be equal to F into, from our key concept we can write it will be equal to F into 2R. So it will be equal to F, we have found out 2K, so it will be equal to 4K R square theta. This will be the moment of force which will rotate it in the counterclockwise direction, because let's suppose one is being 2 is being contracted, so, and 1 is being extended, so it will counteract in this direction counterclockwise. So this will be the moment of F. Now we will find the moment of inertia about the point of contact. It will be equal to ICM plus mr square. So in case of cylinder, ICM is equal to half mr square plus mr square. So it will be equal to 3 by 2 into mr square. So now we can find out the angular torque of the body. So angular torque, we are trying to find the equation of motion for the cylinder. So angular torque, what is angular torque? It will be given by I naught into d2 theta upon dt2. It will be angular acceleration into moment. So it will be equal to 3 by 2 mr square times d2 theta upon dt, it is d2 theta upon dt2. So here it will be dt2. Now we have found angular torque, so we can equate it with the angular torque is found out to be 3 by 2 mr square times d theta 2 upon dt2, d2 theta, sorry, it is, let me correct it. So d2 theta upon dt2, so it will be equal to the moment of force we have found out in negative direction, because angular torque is in clockwise direction, so they are both opposite. It will be equal to minus k r square theta. So from here r square gets cancelled and we get the value of d2 theta upon dt2. It is equal to minus 8 by 3m k into theta. So from here we can write d2 theta upon dt2 plus 8k by 3m into theta is equal to 0. It is similar to the equation, and it is similar to the equation d2 theta upon dt2 plus omega square theta is equal to 0. So by comparing both of these equations, we get the value of omega. So omega comes out to be equal to root of 8k by 3m. So we have omega. Now we have the formula for time period. Time period is equal to 2 pi by omega. So it will be equal to 2 pi into square root of 3m by 8k. Hence it is the expression for the time period without sliding. So we can also calculate it further. So it will be equal to pi times square root of 3m over 2k. So this is our final answer. I hope you understood it well. Thank you.